So Liran, welcome at Codecamp.
Hey everyone, how are you doing?
We're good. We're fine. We can't see you. Do you have a camera?
Yeah, let me turn this one on. Should be good now.
Welcome at Codecamp.
Hello,
So
how are you doing?
First question of the day. So we're good. We're good. The first question of the day is: how was JavaScript originally called?
I didn't saw Java. I think it started with Java and then they added script at the end. What do you think about that?
That's the answer, right? That's the answer. Okay, good. How's life?
As well as it can be these days. So I'm hoping everyone in the conf is healthy and safe. Keep safe. So as long as you're safe, I mean that's 50% in, right?
Definitely.
Yeah. Really honored to have you kicking off the conference today.
Thank you. I'm excited to be here. Thank you for having me. Aside from my talk, there's going to be other great talks around today. So please stay tuned on this very wonderful curation of talks today.
All right, then everyone enjoy the conference. Liran, please go ahead.
You have the floor.
Yeah, and then we'll meet again in like 45 minutes to answer questions, have a nice conversation, whatever we want.
Sounds good. There we go.
Thank you.
Well, everyone, thank you for coming to this talk on packages for mass consumptions, because we are all a lot of consumers of open source packages, NPM, Maven, Ruby gems. Trust me, this actually goes beyond the NPM scope, but since we're talking about front-end and JavaScript here, I'll focus on NPM specifically. My name is Liran Tal. I'm a developer advocate at Snyk, where we build developer-friendly tools to help you as developers build applications in a secure way. So whether you're doing anything around Node, JavaScript, other ecosystems as well, we're there to help you. And I'm specifically on a mission to help you build things in a secure way. So if you have any questions about, security vulnerabilities, what can happen on the front end, on the back end, just reach out. I'm available on Twitter at Liran_Tal. And aside from Snyk, I actually do a lot of other things in the community. I am maintaining an open source project for OWASP. One of them is NodeGoat, which I'm contributing to. Another one is around managing common weakness enumerations. I'm a member of the Node security working group. So again, any questions on any of this, I'd love to talk you into it. If you'd like to join the Node project as a contributor and help manage open source, come on, this is a good time. Reach out, let's talk. So without further ado, let's dive into it. And I want to start with taking you back into a journey of a picture, which I think you may have, we have like started into a journey of using open source, but it didn't really start today. But the shift of using open source, the way that we actually consume it did change. And so maybe you haven't noticed, but there has been a lot of total shift around how we build projects today. Some 10 or maybe 15 years ago, the first thing we did when we started a new project is, we started writing code into the IDE, right? As the need arose to add some libraries, we added them, but we kind of started with a blank page, file new project, and we added code into it. If we got to a point where we needed to, add kind of a drag and drop library, we will just search for it as an open source kind of like library and add it to the project. But today, things are a bit different, right? Today, we start projects using generators, right? Using scaffolders, whether these are, the ng CLI, the Vue, the Create React app. And by default, we already have all of those open source packages, in the project itself. This is like our starting point using open source packages. Now, if you're building all of those, this. And at the end of the day, what happens is our code, and this is the mental model I want you to have in this talk, is our code is really just a slight portion of that. Our actual lines of code is really just, maybe a 10%. That's really the best case, but it's even, it's not there, right? So 90% of the code base is open source packages from different people, different maintainers all around the world, helping us build our projects. So let's talk about what exactly this means, because there are challenges in managing open source dependencies at scales. This is the number of open source packages on NPM, probably a bit outdated for like a month or two, since I know it's already like 1.4 million and it's growing all the time, right? And there's so many other challenges that we'll talk about through this talk. For example, should you use log files? What are they good for? What could be a security nightmare in terms of log files? Like why? what's wrong with a package log JSON or a yarn log JSON. So not saying something is wrong, but something you should look out for. It's coming up in the rest of the talk. How do you keep your dependencies up to date? You know, it's so much a core part of your project, but should you update to patch version, to minor, to major versions? Can you have some automation around this, right? Which we're seeing today, you know, more and more. When is it actually safe to update versus, you know, all the time? What happens if a malicious package can compromise you as a developer? We'll talk about all of this in the talk today. But first, I want to get all the basics out. So I'm going to talk to you about package JSON and 4 levels of different perspectives of dependencies types that you could have in this. So this is like the 4 dimensions of dependencies. So first of all, we have the package JSON. Everyone knows that it has this scripts field in the JSON. You could have things like test and start and something else. I do hope you have something for tests. Tests are important. The other thing is there's the package versus the version, right? This is the first level of dimensions we're going to talk about. There's an explicit package name and a version to it. So there's a package and a version. They can be either dependencies or dev dependencies. So maybe we require debug, 4.10. But then look at this. There could be another project, another dependency, for example, Fastify plugin that might require a different version of debug. And so we actually have 2 versions of debug in the project satisfying our dependencies. This is the first level of dependencies that you should understand that could happen in a project. And of course, you know, there's so many other ways. So understanding this notion of having several versions of the same one, especially for front-end application, is crucial because for front-end, you're actually bundling all of this out. So it just increases your bundle size, and sometimes you may want to be aware of it. So there's different plugins like this Webpack plugin here that can help you understand whether you're using maybe duplicate versions of a package, and maybe you want to do something about it, like maybe fix it. The other thing is, as we're going into it, there are other fields like the licensing and the registry metadata and community metadata about contributors, and you know where you could find some stuff. But really, the crucial part is understanding semantic versioning. This is, I think, one of NPM's greatest virtues in the introducing and popularizing of semantic versioning. It's coined semantic, right? Because it conveys an intent, but one which is not always enforced. So we should actually be very careful still when we're doing it and hope that everyone actually respects semantic versioning. So what actually we're seeing, what is 1.4.6? We have a major version 1, right? This means any major changes, if I'm breaking APIs, I should increase this to let consumer know that something is happening there. If I am doing something that is more of like, you know, minor features and stuff like that, backwards compatibility, what I actually want to have is increase or advance or promote that minor version, right? That minor version is called 4. What happens if I'm doing things like, you know, just really minor updates that are not really new features? I could go and increase or promote that patch version, that last number digiter. The really important thing here that actually translates into security, and that's why we're talking about semantic versioning, is if you are a maintainer of open source packages or contributing to a project, you should know that if you are introducing a security fix to a problem, you should probably advance the minor or the patch version, not the major version, unless this actually requires it if something is breaking. Why? Because consumers who will consume your new fixed version of a security vulnerability, which they want to apply ASAP, they need to get something that they know will not break the app. So if you're fixing something as a security fix for promoting version 1, that's not going to be very well respected in the community. So we have all of these flags like this tilde that says, well, all of this version that is like 1.4, 1.4, 7.49, or you know, all of those minor version and upwards. Sorry, all of those patch versions and upwards. That's what I'm going to be automatically updating, and then I'm not going to update anything. You know, is a minor or is a major version. And if you wanted to have a policy where you're updating everything else, still not a major version, but everything else that is 1.x, you could have that caret sign. The other thing that we should notice about packages is there's these tags, right? This is another perspective of NPM packages. I don't know if you noticed this, but NPM packages actually have tags in them, just like you have in GitHub or something else. A unique package is actually a package and a version, but that version could use an alias to a tag. So for example, when you do npm install package, which version does it actually take, right? Have you ever thought about it? It actually takes the latest version, and the latest tag actually is redirecting and pointing to that, 1.4.3 or something else. You could have different ones. There are actually different ways in terms of naming conventions and what you could have. Different projects have them, like React and Angular, where there's like a next and a stable and a testing and so on. So you could test different packages. If you wanted to see what's going on in your project, you could do something like npm show a specific version, like I'm doing here with Yargs, or npm view, and get all of this extra metadata about it. The other thing with package manifests is, they have this executable CLI. So sometimes packages could be executable and provide you with kind of like a CLI. Sometimes they can have a version compatibility, like say they require a specific version of npm or Node to actually function well. This is mostly geared towards, the backend versus the front end. You could whitelist specific files. This actually says packages, but we're talking about files that could go into the package itself. So if you did, so this is, for example, a good way for you to say, if you have like a config file that has sensitive information inside it, in your project or in your package, you don't want that to go in, right, by default. So what you could do is you could whitelist all of, sorry for using whitelist, actually should use allow list, right? This is wrong, and I'll change it afterwards. But if you wanted to use an allow list of files to add, this is where you do it on the package.json file. Now let's talk about log files, right? Log files, they provide you a lot of benefits, right? I'm pro log files, just you should know how to use them correctly. And that is, they provide you with a way to get a deterministic build. So if you are sharing something with your teammates, with someone else, you ensure that both people or more get the same version, the same dependencies when they install it. So before log files, this has been a bit of a mess on the NPM ecosystem. But with the introduction of those through Yarn, and then later on with package lock, this is something that is a de facto now in projects, and for a good reason. But let's take an example of, what could be a security blind spot in log files. Like, what's the actual security concern here? So as we take a look into it, this is me contributing a pull request to a project, and you can see that I've updated the log file itself. But honestly, like, if I take a look at what the pull request looks like, it kind of looks like that, right? I updated this octorest minor version, this types node, and the log file itself. This is a default behavior by GitHub. What it does is it actually helps me see what are my changes, but for my my log file, it actually rolls that up. So I actually can't see what's going on in the log file. And most people, contributors and maintainers, they don't bother to look at the diff, because the diff, when you expand it, it looks like that. It's very machine generated, has a lot of data inside it, and you don't really care about the changes there. But maybe you should, right? This is the point. For example, I made a change, I contributed and updated the log file, but in the same time, if you look at the middle of the screen, on the right, my change actually replaced the valid MS contribution of the package from being served on registry npm.js.org to actually being served from my own GitHub repository, which is a clone of MS, and it has malicious version of it. So if you actually installed it and used this pull request, merge it or tested it, at the same time you would use it, you'd run an npm install or a yarn install there, you'd actually be downloading my MS version, which could be doing something weird on your development machine. So this is why security issues, they just manifest in so many weird places, including log files, which is something you should be aware of. So for that, I built this tool called logfile.lint. It's both a library and the CLI. You could use it as another linter that you add to the project and make sure that you actually have correct policy. So you could say, I want to validate that everything is from HTTPS. Obviously, you don't want any man-in-the-middle attacks on the wire. But also you could say, I want a policy where I enforce getting sources of packages on my log file only from, say, the Yarn package mirror and npm.js. And anything else that's coming from like GitHub or a GIST or something like that is invalid, and it will fail the build. So this protects you. So log files. But the thing is, how do they get managed? What is going on there? So I wrote a bit more about this. If you're interested in like reading a bit more into like what's the difference between both of them, when are they used? Because log files actually only work on your on like the first party person using the library or the project. log files are not taken into account for dependencies of dependencies. So this just results for the package JSON direct dependencies that are set. So all of that is actually in that blog thing, and that what I'm trying to show you here is exactly how that works. So for example, there's a contributor and the consumer. So the consumer actually gets, if we're using Chuck as an example here, the consumer only gets the direct packages showing up in the package JSON, and the direct packages showing up in the node modules Chuck package JSON. If Chuck itself has a package log file, in a sense, this doesn't get into the consumer, right? So in other words, it's worth understanding and highlighting this. And if you wanted to specifically force all of the direct and indirect versions of the dependencies pulled from all of your dependencies in a project, you could do it using this npm shrink wrap file. This is what it's for. So let's talk about direct and indirect. What is going on there? So direct versus indirect dependencies, it's probably, you all know about this, right? There's like the direct dependencies like production and dev dependencies, right? In my project, for example, I'm using Fastify, and it has inside it something else. But look what's going on. And this is really the interesting part, right? This is where things go really, really bad. And this is the question where how deep does the rabbit hole really goes, right? So let's see what can break, because what happens with indirect dependencies that is actually that much of a concern for us. Let's see. So we start off, this is our project. It actually depends on Fastify. That's great. That's a great framework for Node, the web application framework. It goes on, but Fastify itself has a dependency on AJV. So we pull this one in as well. And AJV has a dependency on URI.js. That's great. Let's pull this one as well. And there we get into URI.js, which has another dependency. All is fine so far. By the way, security research, not security, but academic research has shown that basically you could really have, on average, when you install an npm package, about 4 levels deep of dependencies. So this is actually a really realistic case, right? None of us actually goes in deep and looks at what's going on there. But the question I'm going to ask here for you, what do you think would happen? Do you think, is it possible that this URI.js package could break? Would this break for some reason? What would happen to it? If it does, the whole install process, the whole way of running my app, based on Fastify and AJV and URI.js just tumbles down, it just breaks. But why would it happen? What are the reasons for it to happen? And this is why it is so important to understand. So let's take a nice and interesting journey of what could happen. And I'll show you what really happened as a story, which I don't know if all of you remember, but we'll go into it in a second. So why would a package break? First of all of these packages could have breaking changes in the API. And so this is something that we talked about before, right? The semantic versioning, which people do not enforce, maintainers may not enforce, by accident could happen. No one is saying, people are evil here, but it could happen. And so what I actually want to stress here is that all of these are going to account to like real significant disruptions for you when you build or deploy your production app. Other reasons could be a package has been compromised. For example, did you know Express, got compromised in a sense. I'll explain what I'm meaning by compromise. And React and debug, all of those. A security researcher a couple of years back working with the Node and the Node technical steering committee, what actually happened is they had a research going on into the use of good passwords and accounts compromise on npm.js. So the result of their research, this is kind of like a good citizen trying to help us out, but they're doing it from externally testing the system. So they actually managed to get access to a whole lot of modules on NPM, accounting to 20% of all of NPM downloads in a month. This is a couple of years back, and they were able to get publish access to those packages like React and like Express and like debug. And it means that the package could get compromised. For example, mail parser, a mail client for Node, got compromised. It has it really compromised, right? Like not from a security kind of like a pen test thing, and it had like 500,000 downloads a month. So this is like real things that are happening. So this could happen. Another thing that could happen, npm.js could be unavailable. That could happen as well. Network disruptions from your end. Maybe a maintainer pulled down the package and it's not anymore available. Let's take a second and think about it. Like, let's say all of the rest are, could happen. Why would a maintainer pull down a package? Why would a maintainer remove the package URI.js or Angular or something else from the registry? Why would can it really happen? Is the NPM not protecting us from that? This actually happened. It broke a lot of things. Let's see what happened there. Yes, the maintainer actually pulled down the package. The story is this is open source, right? So everyone can kind of do as they please in a sense. You could publish malicious packages. Maybe NPM stuff catches it, maybe not. What's the worst that could happen? Let's see. So the story begins with this. There's this person called Azar who unpublished nearly 300 packages, on a day, notably including one called LeftPad, which was used by top projects like Node and Babel. So the NPM team unpublished, unpublished LeftPad in a sense. But the thing is, the remaining packages that were exposed for this kind of like malicious actors to grab it, because sorry, what happens is if NPM unpublished it, it means someone needed to push it in. So let's talk a little more about the story, right? This lawyer, there was a lawsuit related to this. So this is like why it actually happened, right? There was kind of like a copyright about this module called Kik, which Azar refused to remove ownership and provide it to this company. But the NPM staff intervened, and they did change forcibly ownership and moved that ownership of the plugin of the package from Azar to this company. As an act of protest, Azar actually removed all of his modules, including that one thing called LeftPad, which is somewhat of an 18 lines of code there, that just pads a string from left, and that's okay. But who depends on this, right? Webpack and Babel and JCS and all of those linters. And what happened is, this broke a lot of system. This was like a whole thing that actually disrupted the ecosystem. So let's go back to the story, right? Reminder, at this point, if you follow the storyline, LeftPad is now unpublished, right? Unpublished. Someone removed it, so someone else could do something else. And that's exactly what happened. There's this person called Cameron Westland who actually published a new LeftPad package into this ecosystem. But what is going on? What if that person who just, because NPM removed that, because Azar removed all of his modules, including LeftPad, none of them anymore exist on the package registry on NPM, but projects still depend on LeftPad. So it was breaking a lot of builds. Cameron pushed in this new package as now an owner for it, because that namespace was now free. Again, what would happen if that was a malicious user? At that same moment, that package would be distributed, part of a download of all of those millions of builds running in the wild. Luckily, it wasn't, right? Luckily, Cameron was a good citizen, just trying to kind of like, continue, get the builds all green and, get everything back in order. But this could have happened. There was nothing there to prevent it. So, many builds were still broken. NPM tried to republish this from backups. This was a total downtime of 2.5 hours, which is critical for some systems. But you could understand the impact and the amount of stress this was causing on the ecosystem. So back to that research article I told you about, right? If we take into account other ecosystems, which are far different from the way NPM works, you could see that, for example, on an average, an NPM install gets those 4.39 levels deep of dependencies, right? This is what we're talking about. So remember I told you about those packages that has been compromised? There we go. 14% of NPM modules were compromised. They account for those 20% of NPM total monthly downloads that I told you about. This is a work of a security researcher, and they basically evaluated those weak NPM credentials, and his results was shocking, right? This is it. React, moment, debug, request, all of those, he managed to gain publish access to all of them. Like, how can it happen? How did someone gain access to these popular modules? Well, more than 1,000 of users had their password set to their username. Quad developer had their password set to password, like plain text, that like literally the word password. 11% of those users actually had reused their passwords that were leaked in database breaches that were actually reusing them. So all of this really happened. No one did anything malicious because this was an active research, but they did get access to all of those packages. So conclusion here, please enable 2FA. If you haven't already enabled two-factor authentication across your your GitHub, your Docker Hub, your NPM, your Python, whatever, do it. This is literally important to protect all of us citizens of open source. Let's talk about enterprise readiness, right? Why do you need a local NPM proxy? We talked about a lot of things that could go up, like network disruptions. Maybe NPM is unavailable, which could happen sometimes. But why do you need it? So it may happen, right? NPM could be down. I don't know if it happened to you, if you experienced it, but here's a screenshot from a while back. You see the downtimes in red for NPM, right? And it's not to put anyone in a bad light, right? Like everyone gets downtime, that's okay, but you need just for yourself as an enterprise readiness tool to have something that would protect you when that happens, things like caches and so on. So why do you need it? Because maybe the network is disrupted. By the way, maybe it could happen on your end, not on NPM's end, right? Maybe bandwidth considerations, because we're doing those NPM installs and they take a whole lot of time, right, from the day-to-day routines. So if you could get something that's a local NPM proxy, it also means you cache things for the entire team, not just for you when you do those local NPM or yarn installs. So all of these things kind of help you out. So what I actually want to talk to you about is an example where Webpack, as a case, is so big, right? That version specifically is pulling in 24 direct dependencies, almost 2,000 total dependencies when you pull this in. The network requests, again, 2K requests, and almost 200 megabytes of just unzipped on the disk. So what more could happen that we have learned from what happened with LeftPad is packages could get suddenly yanked, right? What happened with LeftPad? And if you have this local NPM proxy in your organization, in your team, it protects you from these things because it exists there for a specific period of time, and it doesn't need to go all the time to the source repository like NPM, which could, as we've seen, get packages disappearing. We call them yanked packages. And again, when you have this as a local NPM proxy as like a service, it's not something that a team member has it specifically for their own cache or local cache, because this is serving everyone else. Private packages on NPM, which you could also want a proxy for, they kind of cost money. So you could do that if that makes sense. But this is where I want to bring in something else. An open source project called Verdaccio. If you haven't used it, if you're not, haven't heard about this today, try it out. It has like a Docker image for it. It has, it's an NPM package as well as you could just run it off. It's basically a lightweight, private NPM proxy for use. So it's not going to download everything locally. Like it's not going to mirror the entire 1.4 million packages on NPM. It's just going to cache them with requests. So it has this whole user management and this new React interface that they've built. Check it out. It's a good lifesaver for all of those issues that we just discussed about. What about automating this dependency management, right? Because many dependencies exist in our projects, and also like they span out, like different microservices create this need to include this automation, because it's not just a project, one project you're maintaining, it's a whole lot of it. So you need to be up to date across different projects, different microservices, different, micro front-end or front-end projects and so on. So you need a way to actually automate dependency management. We just talked about how, increasingly difficult this space is of managing dependencies, right? So we need to do this at scale. We need to do this with tools that help us do it. So, here I'm using Snyk for both of my security fixes and my automatic pull requests. I just upgraded dependency. In this case, this is Pino, a small and fast JavaScript logger that I am getting automatic pull requests to update to a new minor release. But the thing is, I want to be mindful about what I'm getting updates for. So it's really cool that Snyk is opening this pull request for me. But also what I actually want to look at from that pull request is pulling data, like what is what was the latest version that got released? How far is it behind? If I want a quick access to this release notes or commit messages to see what exactly changed and vet it before I actually merge it. So all of that is in, and that is something to help you. But a lot of tools have some of these capabilities, which is great. The thing is, for me as a developer, I do not want to get spammed and get hundreds or tens of pull requests every day saying upgrade debug, upgrade Angular, upgrade Vuetify, upgrade Bootstrap, upgrade whatever. Don't want to get into that because I'm just getting all of my time into merging pull requests from bot. what instead I would want is something that kind of streamlines it, right? And that's where, for example, on my Snyk repositories, what I'm able to do is in the Snyk UI, I can go and configure and say, well, I want to get dependency upgrades only for patch and minor versions. But more than this, I also want to say, I want the bot, the Snyk bot, to actually limit all of my open pull requests, both for security and for dependency upgrades, only to a minimal amount, right? To a 5, to a 10, to a 2, whatever you are comfortable to deal with on a day-to-day basis. But I don't want, to go to the repository and see, a list of 10 or 20 upgrades for like all of my dependencies, because that's going to be a nightmare for me to maintain, and I'll be working all day just merging pull requests. So I can do this, and this helps me kind of like get to that backlog of updating dependencies, but on my time, right? When I am used to it. So what about if you wanted to ignore dependencies? What if you do not want to get all of, like, for example, Jest or Semantic Release or other packages that actually have a lot of releases, like minor and patch version releases happening all the time? So what happens if you want to just ignore something? You don't want to update it. There's a reason where you do not want to upgrade a dependency, right? Again, in the tool, you could go and say, I want to ignore specific packages. Helps you be productive. So this would be a good time to raise questions from the crowd or flowing. If you want to open this up, and if there are any questions, this is a good time. If not, I've kind of prepared like this, question, like a problem and an answer, kind of like seeded questions here that we could go through. So, but before that, I really do want to see if there's any questions that we should go through. Let me open my own chat.
So Liran, not so far. I think people are still digesting what you're presenting.
All right, cool. So I'll go through it. This is a good time if you wanted to share, raise any questions, go ahead and add it in the Q&A or the chat. I'll go through this. I've kind of prepared some of this, and these are more like, I called it pro patterns for teams, right? How do you be productive, and what could happen? So for example, let's start, right? My problem is my CI builds are slow, right? And they aren't deterministic with development. What happens is a log file is not enough, because a log file guarantees deterministic builds. But if you actually create a pull request that just updates, for example, the package JSON, but not the log file, what happens is like a regular npm install or a yarn install will still install it and then update the log file accordingly. But this happens on the CI, right? So what you actually want is the CI to fail if someone forgot to update the log file as well. So to do that, you need to use npm CI or yarn install and that -- frozen log file. It's both more speedy, and then it's kind of like I call it surprise-free builds, because the builds really are deterministic, and also it fails them. There are no surprises, right? If someone changed the package JSON, the build fails at that point if they haven't added anything on the log file. Another one is, for example, my developers often can't reproduce the bug in production in their environment, which I've seen happening sometimes. Not everyone know about NVM, which is a Node version manager. Maybe they used it to kind of like install and manage some versions of Node in their development environment. But the cool thing is, you could have an NVM RC file, like a configuration file for the project. So what you could do is basically the project itself, the backend or frontend, it has a configuration where every time you kind of like cd change directory into that project directory, it actually uses the same version for all of the engineers, right? For everyone working on the project, that that same version that you probably have in production, presumably, right? So you can be everyone on the same page in a sense. Another question that you may have is, for example, I'm concerned installing Node.js modules because I'm afraid they're going to run malicious code. Now, we've seen this happening a couple of times, well, actually more than a couple of times, probably like a dozen of times on the NPM registry. And by the way, malicious packages, like if you open like any advisories database, like if you open snyk.io/vuln and you go and you see all of those malicious packages on NPM, it's like something for like 2 months back, right? It's always happening. And so what their most common vector is, they would actually go ahead and do something like put a post install or pre-install script where when the package gets installed by npm or yarn, it actually executes something. So maybe taking your config files with sensitive data, maybe taking your environment variables, sending them to someone else, maybe reading your npm-rc file, which is your token for npm. So if you're a maintainer, this is super important because then they will have access to npm instead of you. So they could do all of those things. So the solution, that's it. npm install whatever ignore scripts, and that will not run any of the scripts, the pred, the process, all of those lifecycle scripts or hooks. They will not run, so you could protect yourself with that. There's another way that you could do it automatically, which is to configure it globally. But if you do that, that is actually not going to run any other scripts in the project, like npm run test for your. So it's like, I don't know, it's counterintuitive. I do not do that. Instead, what I do is I actually developed this tool called npq, which is kind of like a wrapper around npm. So when you do npm install, npq actually goes there, search for data in the package that you want to download. Like, how many downloads does it have? Is it something like 20 downloads? Probably new. I do not want to use it. Maybe it's something malicious. Does it have install scripts? It will tell you about it and warn you before you install it. So you could use that. So yeah, all of those we covered. What about if you're using packages with known security vulnerabilities? Well, you have two options. npm by default has npm audit. There's OWASP dependency check, which is another fallback for open source stuff. You could use Snyk test, which is what I'm doing basically. It has, from what I've seen, a bit more coverage than other like npm audit or OWASP dependency check, because Snyk does this security research and intelligence. So for example, I have this demo with Vuetify, right? Vuetify is a Vue, like a UI component library for Vue.js for people who have difficulties with CSS like myself. So I'm using this one, and apparently there's a XSS vulnerability in Vuetify that existed since 2019. But when I installed it with npm, I didn't find it, and npm did not report any vulnerabilities, but Snyk did, because Snyk has this just better coverage on npm vulnerabilities beyond, like what's like a formal vulnerability report called CVEs. So you could use that. Snyk is, by the way, free for private projects and open source projects. You could just, go ahead and use it. Understand, this will give you a good understanding of just the dependencies you use and all of those package health issues. So what happens if someone compromises my npm account and distributes malicious packages, or does what happened with event stream, which is basically inject another dependency that is actually malicious? So I've talked about it, for a couple of times here in this talk, right? Enable 2FA, do it from the UI, do it from the CLI, do it whenever you want. Just enable two-factor authentication. It's an important thing to make sure that everyone on your team or on your project actually have this. Couple more to go. So what happens if you accidentally leaked some secrets in a config file when you published a package? So there are two things that you could do here. One I talked about really briefly, but I did in the beginning here, which was if you are if you're using the files key, which accepts an array in the package JSON file, what happens is you could state all of those files that actually want to be bundled into this tarball, this tar file that is actually your package. This is one way of doing it. Just sometimes kind of a bit, not too much, but a bit of counterintuitive sometimes, because for example, you add a new file or something and then you forget adding it to files and you publish the package, and then well, it doesn't really work as you expected for consumers because you just forgot to add it into the allow list files array. So for that, use files if you can. For this problem, what I actually found is I have set up end-to-end tests for publishing a package. So actually in some of my projects were like CLIs, what I actually do is my end-to-end pipeline for a project spins up Verdaccio as a local npm, like a proxy thing, and then it creates the npm package, it publishes it into this Verdaccio thing, which is just a container running on the end-to-end CI pipeline. And then it actually tries to install it and run some CLI commands to sanity test it. So this might be a bit of an overkill for most packages, but it helps. Some of my repos have, I can give you if you needed to example of references of how I did that in my repositories. So if you wanted to reach out, I'll help you through this. The other thing that you could do is use detect secrets, right? If you're afraid of leaking files. This is actually something I've done for Verdaccio, which is detect secrets is actually an npm package and a Docker image that what they do is we implemented it as like a Git pre-commit hook for some projects like Verdaccio. And when you add a new, like when you do Git add and Git commit and all of those things, you add a new file, it actually goes through it and sees if there's something that is like a sensitive keyword, or like that looks like a password or an API key or something like that. And if so, it drops, it fails the commit. So you could actually, not commit that in. So you could use that. If you want to see how that looks like, you can go to GitHub Verdaccio/Verdaccio, see how we implemented it. I can give you the pull request ID as well that you could see for reference if you wanted to like add that to your project as well. It's a nice, really, developer-friendly tooling for you to avoid it. So all of those things to do it that help you manage those leaking secrets in your published packages. So what if you want more ideas and more, more tips, right? There's the Snyk blog, which I maintain some cheat sheets. So I have like an NPM security cheat sheet that covers some of these things, some more as well. If you wanted to like reach out and learn more of this, just reach out. I'm here on the conference. Just reach out on the chat or send me an email or reach me out at GitHub or Twitter. And let's talk, right? So thank you so much. I really hope you enjoyed it. You learned something new. And this is a good time for questions. So there we go. Back to you, Florian.
So we thank you, Liran. So about Snyk, what are the most popular features that people use in Snyk? Could you tell us a bit more about those things? I'm sure you're investing in something like a top list of features that people.
Yeah, great question. I guess it really depends on the persona, like the person who wants to use Snyk. Like for teams, for example, for like bigger enterprises teams, one of the cool things that Snyk has is we cover like more than NPM, right? For Java, for Maven, for Ruby Gem. So you often have these teams that are like that are polyglot, right? They do the backend in Java, the front end in Angular or something, and they need a solution. So like having NPM audit for the front end is nice, right? It's a great tool for like the default security stuff to create awareness. But then what do you do for Java, right? The rest of the team kept behind. So I think one of the things of having like one tool kind of like to help you with everything and streamlines a lot of that is that that Snyk kind of covers all of it. For other people, like for example, one of the really cool things I like about Snyk is like two things around vulnerabilities, right? I do a lot of like security research myself in some of these areas, some of those tools. And one of the things that I really like is often unknown about Snyk is when you get those pull requests, like a lot of people do this pull request today, right? Like they enable that on GitHub or something. But what Snyk does is Snyk actually looks at what is the most minimal semver version to upgrade your package with that security fix. So for example, if you have, I don't know, like React version 16, and it has 16.1 has a security issue, and 16.2 has a security fix. But there's already 17 outside as well, which fixes the problem. A lot of tooling will just, even NPM by default, like if you do NPM audit fix or something, it just upgrades to the latest version. It will just move you from 16 to 17 because that's the latest version that fixes it. But Snyk is more like, it's like a super developer-friendly tool, right? The point is, we want to make it easy for developers because we want to help them out. So we actually, when we open the pull request, we will upgrade you from React 16.1 to 16.2 to get you like the most minimal thing. More than this, actually, sometimes you may not have a security fix available for some projects, right? This is open source. People, have their own lives. So like something could be popular, but not really maintained well. A good example of this is Marked. If you're doing Markdown on the front end or the back end, Marked is an NPM package that spans, I think, 3-point-something million weekly downloads. Like this is a very popular package. A few years back, what happened is someone opened an issue, actually with a pull request that showed an XSS issue in Marked with a pull request with a test to fix it. Like that's like the best pull request you could get, right? Just land it in, release it, make the fix available for everyone. But what happened is, unfortunately, that the Marked a few years back was not very well maintained, having millions of downloads still and consumers using it on the front end or the back end. And what happened is the vulnerability was publicly known, like everyone could have just seen how to do an XSS on a website that uses marked. This was publicly known as an open issue, but it had no actual fix. So Snyk, not a lot of people knows this, but Snyk actually maintains patches and it's freely available in open source. So what happened is, even though there was not an actual fix that you could upgrade, like there's no release of marked for that when that happened, you could still do something like the Snyk CLI does, like a Snyk protect, and it applies the patch with the security fix specifically like on your node modules project to add the security patch. So you are protected, at that point without even having an actual fix. So yeah, I'm gonna close with that. But Snyk is super awesome. There's like a lot of things inside it. It's free and open source, like the CLI. It's free for private projects, for open source projects. Just try it out. If you wanna just ping me about your feedback about it, I'd love to hear it. So definitely do it.
But Liran, we're not going to stop now. No, we've got more questions. So the next question would be, when people think of Snyk, what's on their wish list? When they think of features they would like to have. So what's missing actually? Because all tools are great, are beautiful, but what's missing?
Amazing question. We just announced, like last week, we had SnykCon, the first ever Snyk conference, and we announced, I can publicly share this now, we announced that Snyk is going to do this new product launch called Snyk Code. Now, a lot of tools, let me tell you an example, right? This is a headache for everyone. What is the headache? People get security vulnerability reports from tools like Snyk and npm audit that says your jest or I don't know, whatever, something else library is vulnerable because of prototype pollution or XSS or something else. Now the headache is here, where a lot of times, or oftentimes, that vulnerable function in that deeper library like Lodash or something, maybe you're not using it. So the library could have this vulnerability, but your code doesn't make use of that function. So realistically, you are not actually vulnerable. Now, this is this is a prioritization issue. Like the developers they do an npm install, boom, 1,000 vulnerabilities, right? The thing is, how do we tell you which one of them are actually reachable from your code? So this goes back now into Snyk. Snyk actually released a few months back this thing called Reachable Vulnerabilities. It's for now only available for Java. We'll soon be able to release that for JavaScript as well. But what it does is this feature when you do a Snyk test, right? Like you do npm audit or something like that. So the same thing, you do a Snyk test from the CLI, -- reachable vulns. What happens on Java projects, it will actually do a call graph analysis of everything from your code to dependencies in your POM files. And only if it matches like a direct graph where your code actually calls a vulnerable method, not the whole library, but the function that is actually vulnerable, right? Only then Snyk will tell you that you have vulnerabilities. So this is super crucial because developers, they have a lot of things to do. I know what they don't want to do. They don't want to start triaging vulnerabilities all of their time because they need to do a lot of other things as well. So you want to make them productive, right? You want to let them focus on the security vulnerabilities that are realistic. So I mean, that's the reachable vulnerabilities that we have for Java. We'll soon have it for JavaScript and other ecosystems as well. It's going to be amazing for JavaScript developers. And now connecting back to what I think was missing on the Snyk side was what happens, what are security issues on your code, right? Not just dependencies, but even if your code is a 2% or 10% of the entire app, because it's a lot of dependencies, your code is still important, right? And so Snyk actually announced we were acquiring this company called Deep Code AI. So there's this new product called Snyk Code, and this is going to help you, straight from your IDE into understanding where vulnerabilities exist in your own code. And there's a whole demo in the website where we do it from the IDE. And what the cool thing that I like about this demo is, and the product in general, is it actually shows you example of fixes from other repositories. So for example, if it will tell you, oh, I found this SQL injection in Java Hibernate or in Node.js as a CLIs, it, in your code that is not using it correctly. So this is still your code, you're not concatenating, you're concatenating strings instead of properly embedding the library using binding parameters. it will show you fixes of how other people actually fixed it from other open source projects. So this is like amazing. You are learning from others. It's like viewing Stack Overflow for security in your IDE. It's super incredible.
Sounds
so
very
I'm really
cool.
excited for that one.
It sounds very cool. So one final question before introducing a special guest, the other special guest we have, surprise guest. So I thought Google knows it all and has it all, and I've seen that Google uses Snyk, or people from Google, or why is it on your website?
Yeah, right. So Snyk, Google is a customer, I think, Intuit, Facebook. A lot of people are customers of Snyk. The reason for that is, obviously, the good product and everything. But again, it's that thing that people, I don't think it's transparent to them. They don't think about it too much. And that is the comprehensiveness of the vulnerability database. Like, this is beyond the capabilities, the feature of the product. This is the database itself. The database of vulnerabilities known in Snyk is like the leading in the industry, right? That's like Google and everyone else use it, because we find vulnerabilities faster than everyone else does, and we actually triage them. So if there's a new vulnerability report for, say, I don't know, Angular or something, maybe NVD, which is kind of like the formal entity around vulnerabilities, maybe they give it like a 6.7 score, out of a 10, right? We triage those as well. There's a dedicated security team at Snyk that says, triages every vulnerability report and says, actually, you know what? That's not a 6 score. That's like an 8.9, right? This is the real impact, and so on. So we find those things super fast. I think for Angular, by the way, the Snyk vulnerability database, it reports on like 26 or 28 vulnerabilities for Angular itself. This is Angular.js. It's like the first Angular one. Angular, the new version, 2 and above, are actually super secure. I haven't found any vulnerabilities there in like the package itself. But if you scan that project, if you install, Angular 1.6 or something, with npm, you'll probably get 0 reports. And I actually have a blog post around it. But npm, but Snyk test, it will give you something like 20 reports of vulnerabilities. So we have this comprehensiveness, and people may not understand this, but it's super important, because we actually tell you that you have vulnerabilities. And if you don't know about them, it's like a false positive, right? It's like, maybe it's secure, I don't know.
Yeah, got it. So amazing talk. But before we break, would like to introduce the special guest, the surprise guest. Idan is here with us.
Idan!
Liran, hey guys.
Hey!
Liran, amazing talk, and I want everyone to know that Snyk is an amazing product. We use it every day, and it's a lifesaver in terms of security, and Liran is doing an amazing job there. Great talk, Liran. Thank you so much.
You're just saying that because Liran is here, right?
Yes, of course. After the talk will finish, I'll tell you what I really think.
All right. So Liran, thank you so much for this talk. Hope to meet you soon in Romania. Let's hope for the best.
Same here. Hope we all meet together. Stay everyone for the rest of the talk. Idan has a great talk, and he's an amazing speaker. He's just being modest here, but you are in for a great treat of the next hour. So stay in, tune in. It's going to teach you a lot about Angular and Firebase. So good luck, Idan, and bye everyone. Bye, Florin.
Bye, Liran. Have a great day.